There's been a lot of discussion when we talk to people about efficiencies of furnaces. So we've talked about 80% efficiencies, 90, 95, 96% efficiency furnaces. And so should somebody get a gas furnace and or an electric furnace? And so the question comes about what is more energy efficient. Now you have to understand that there are two competing factors out there competing for your business. You have the gas company and you have the people who produce electric. So you have to understand where gas comes from. We are in an era right now that we're exposed to a lot of areas that we're looking for more natural gas and natural gas is a fossil fuel. So there was studies that have been done that have actually shown where the fossil fuel grid, the demand keeps continuing to go up while the supply continues to go down. Those two curves passed each other years and years ago, probably 10 to 15 years ago, where our demand has far exceeded what the supply has been. Therefore, it's made an issue on where we're getting our fossil fuels actually from. So we have to be very considerate of that. As an energy auditor, one thing that is looked at when we're evaluating the efficiencies of appliances, we take everything and we convert everything back into what we call kW, which is kilowatts. So BTUs, that's a gas measurement, British thermal unit. That's a gas measurement. We take everything kW and convert it to BTUs. So because of that, we're making a side-by-side comparison of whether the kW is electric versus gas is more energy efficient. Well, it's actually been shown that electricity is actually more energy efficient than what the gas furnaces are. Whether it's a 90, 95% efficiency furnace, an 80% efficiency furnace, if it's a gas furnace, they still need to be serviced. Need to be serviced every year is my recommendation. A lot of times it's out of sight, out of mind. We don't pay any attention to it until it breaks down. Well, you have to understand that gas has moisture in it. And regardless of the efficiencies of the furnace, that moisture and that heat take all types of implications on the interior components of the gas furnace, i.e. the heat exchangers and how that air is being actually heated and moved through the house. If a heat exchanger cracks because of rust and corrosion and those types of things, it could actually be allowing CO, carbon monoxide, to be intermixed with the air that you're actually breathing inside of a house. As a quick reference, a lot of times I tell people if you see white carbon deposits, things of that nature, the white chalky dust type of stuff in your furnace, that's actually unburned carbon. The furnace isn't burning as clean as what it should, so therefore it does need to be serviced. If on the other hand you take an electric furnace, there's very little maintenance that needs to be done with an electric furnace. I typically tell people once every 3 to 5 years, make sure that all the heating coils and the heating elements are work. It's like, as an example, having a toaster. It's no more than a bunch of little heating elements in there, and it's heating your food, okay? It's the same principle with an air furnace or electric furnace as far as heating the air that's being distributed to the house. The combination, although, when we look at furnaces and really what makes up a good heating system in our house, we hear a lot about heat pumps and what's the benefit of actually having a heat pump in coordination with our furnace. One thing is that heat pumps will come on prior to the ambient Fahrenheit temperature reaching somewhere around, say, around 40 degrees Fahrenheit. The heat pump will basically provide the heating that's necessary using the furnace as a distribution source to distribute the air to the house. But sometimes the furnace doesn't actually come on until the ambient temperature reaches less than, let's say, around 40 degrees, 40, 45 degrees Fahrenheit. Talk to a professional HVAC contractor for more information on that. Although being the case, so if the heat pump is your primary source that's using electricity, as the heat pump goes to produce the heated air, again being used by the exchange system of the furnace to move the air, it's actually more efficient. And when the temperature drops below 40 degrees Fahrenheit, then both units are working in conjunction to produce your heat for the house. The other benefit of the heat pump is that you have to understand it's a big fan type of module and it's typically located on the exterior of your house. Being that there's a fan in there, the fan will spin one way in the wintertime and it will spin the opposite way in the summertime. I mentioned earlier that water holds its heat really, really well. If we can hold the water onto the heat or onto the air over time, it's easier to heat that product, right? And so therefore, being easier to heat it, the furnace doesn't have to work as hard to heat the ambient air that's around it, okay? So in the wintertime, the fan spins one way, basically holding the water vapor to the air, so it's easier to heat the air to distribute to your house. Now in the summertime, it turns just the opposite. So as we all probably have known or seen, a lot of times you'll see, like, let's say a window air conditioner you'll have in your house, and it'll be sitting there, and all summer long while it's running, it's just streaming down water, right? Well, what it's doing is actually taking the water off of the air vapor so it can cool the air more efficiently. So it's not trying to cool the water in conjunction with the air. So it's actually, a heat pump actually will spin the opposite way, extracting the water off the air vapor so it doesn't have to heat the water and the air in combination. So the benefit of a heat pump is significant. We're talking about energy efficiencies. It's actually been shown that an electric furnace with a heat pump is more energy efficient and cost effective than running a gas furnace, even with a heat pump.